Hello, space enthusiasts. Welcome back to our channel. Today we're diving into an astonishing development in astronomy. Scientists using the James Webb Space Telescope, JWST, have recently captured an image that suggests something unexpected and potentially unsettling about our universe. Stick around as we explore what this could mean for our understanding of the cosmos. Have you ever wondered if everything we know about the universe might be wrong? Imagine standing on the edge of a cosmic frontier, peering out into the vast unknown through the lens of the most advanced technology humanity has ever built. This is the tale of modern astronomy, a saga of discovery and doubt, where the old meets the new in a clash of celestial titans. Our story begins in the hallowed halls of Oxford University, where Professor Sayer Sakar, a leading figure in astronomy and cosmology, challenges the foundations of a model first formulated in 1922. This model has served us well, offering a coherent picture of the cosmos for nearly a century. Yet recent revelations from the James Webb Telescope have sent shockwaves through the scientific community, suggesting that these age-old theories might not just be incomplete, they could be fundamentally flawed. The James Webb Telescope, a marvel of modern science, has provided us with breathtaking images that are more than just a feast for the eyes, they are a puzzle for the mind. These images suggest anomalies that do not fit within our current understanding of the universe. According to Professor Sakar, it's a wake-up call to the academic world, urging that we cannot continue to teach what might be outdated concepts in our schools and universities. The stakes are high, as the integrity of future scientific education hangs in the balance. In a recent gathering, some of the world's top astronomers convened to discuss what has been termed the biggest crisis in contemporary cosmology. The consensus is clear. The universe is not behaving as expected. Our old rules no longer apply, and these discrepancies suggest that we might be on the brink of a scientific revolution. But is it possible that a century of astronomical work could be in vain? Or can we salvage parts of our old worldview to blend with new discoveries? The truth lies in the data, dense and rich, beckoning the brightest minds to decipher its secrets. As we stand at this crossroads of knowledge, the path forward is fraught with challenges, yet brimming with potential. Is it possible that our universe isn't the seamless cosmic quilt we once thought it to be? This question shakes the very pillars of cosmology, particularly the principle of homogeneity, the idea that the universe is the same everywhere. This fundamental concept is now under scrutiny, prompted by the latest findings that suggest a universe more chaotic and varied than previously imagined. At the heart of London, within the storied walls of the Royal Society, a historic gathering took place. This prestigious institution summoned a cadre of the world's leading astronomers and cosmologists, heralding what many are now calling the dawn of a new era in cosmic understanding. The dialogue at this illustrious assembly was charged with urgency. The acknowledgement that our century-old theories might no longer hold water in the face of current astronomical evidence. The crux of the matter is a striking contradiction between what we see in the sky and what our theories predict. It seems increasingly likely that while our observational data might be accurate, our interpretations of these observations have been fundamentally flawed for decades. Something is wrong, the experts agree, the universe can't possibly look like this. Consider for a moment the idea that the universe today should essentially mirror its state shortly after the Big Bang. Astronomers often use the analogy of a balloon to explain this. As the balloon expands, the dots and patterns on its surface, the galaxies and cosmic structures move and evolve, yet their fundamental relationships remain constant. By tracing back through the cosmic microwave background radiation, scientists have long deduced the universe's basic structures from its earliest moments. Classical cosmology, with its notions of uniform expansion and a static overall pattern, assumed a cosmos that followed these simple, orderly rules. However, these recent gatherings and discussions among top experts suggest that our universe might not be as orderly or uniform as these models suggest. The universe, in its mysterious expanse, appears to challenge the very laws we thought governed it. Is our universe truly uniform? resembling an evenly sprinkled cake as theories like the Big Bang suggest? According to the fundamental principles of cosmology, on large scales, the universe should appear homogeneous and isotropic, looking the same in all directions with an even distribution of matter and energy. These principles are pillars upon which much of modern cosmology rests. However, the universe might have a different story to tell, one of anomalies and cosmic quirks that challenge this notion of uniformity. Enter the James Webb Space Telescope, JWST, launched in the summer of 2022. This technological marvel has shifted the paradigm of astronomical observation by revealing images and data that pose significant challenges to our basic assumptions about the cosmos. The JWST has unearthed structures in the early universe that are so massive and complex, they seem to laugh in the face of the idea that everything should be evenly distributed. Imagine finding lumps of icing and barren spots on what was expected to be a perfectly smooth cake. These aren't mere blips in the data, but large clusters of galaxies and unusual distributions of quasars existing far earlier than expected, suggesting a cosmos that is anything but uniform. These groundbreaking discoveries are not just anomalies, they are signposts that our understanding of the universe's structure may need a major overhaul. Each new image from the JWST serves as a puzzle piece, hinting that the universe might be more varied and intricate than our current models can explain. Could our universe be more like a lopsided cake than the smooth, evenly frosted dessert we imagined? The strange distribution of quasars, the extremely luminous cores of distant galaxies, suggests just that. Observations have shown one side of the universe has a quasar density roughly 5% higher than the other, a cosmic imbalance akin to cake icing that's piled too high on one side, threatening the entire dessert's equilibrium. This asymmetry challenges the very foundations of cosmological theory, which posits that such large-scale structures should be uniformly dispersed. Yet, the reality observed through powerful telescopes paints a different picture, one of startling complexity and unexpected patterns. Among the most baffling structures that defy these old models are the Great Ring and the Giant Arc, discovered by a young astronomer, Alexia Lopez, and her team. Their research into large-scale structures, consisting of galaxies and galaxy clusters, has unveiled formations that stretch the imagination and our scientific models. These formations extend over scales that, according to standard theory, should be smooth and featureless. Yet they are anything but. The Giant Ring, a colossal ring structure formed by a group of 9 gamma-ray bursts, stands out as particularly enigmatic. These bursts are roughly equidistant from Earth, forming a ring with a diameter of about 5.6 billion light-years, making it one of the largest known structures in the observable universe. These astonishing discoveries serve as a reminder that our universe might not conform to the tidy models we've constructed. Each new observation challenges us to rethink and possibly rewrite the cosmic rulebook. Is it possible that the universe, in its vast expanse, is defying the very laws we've set to describe it? The sheer size of structures like the Great Ring and the Great Arc challenges the standard model of cosmology, which maintains that beyond about 2 billion light-years, the universe's distribution of matter should be uniform. Yet, here we are, facing cosmic giants that disrupt this smooth narrative. The Great Arc, for example, is not just a random assortment of galaxies. It is an almost uniformly aligned group that stretches across 1/10 of the entire known sky. This colossal structure undermines the cosmological principle that argues there should be no preferred directions or regions of higher density on such grand scales. It's as if the universe itself is choosing favorites in a game where all parts were supposed to have an equal chance. This isn't the first time our cosmic models have been put to the test. Long before the James Webb Space Telescope, JWST, started peering into the depths of space, the Hubble Space Telescope was already sending back data that occasionally bucked the trend of standard cosmology. These anomalies, these exceptions to the rule, have always been there, whispering doubts about our understanding of the cosmos. In science, as in life, Exceptions are often said to prove the rule. This means that outliers, on their own, don't necessarily overturn established theories. However, when these exceptions start to pile up, as they have been with increasing frequency, it forces us to reconsider. Are these anomalies mere quirks, or are they indications of fundamental flaws in our understanding? With every new discovery, astronomers and cosmologists are pushed to reevaluate, adapt, and sometimes even overhaul long-held beliefs about the universe. As we continue to uncover more about our cosmos, the more it seems to revel in its mysteries, challenging us to keep up. What happens when the exceptions in science begin to stack up, forming their own set of rules? In cosmology, this scenario is not just theoretical, it's happening right now. The very existence of structures like the Big Ring and the giant arc is challenging the traditional understanding that dark matter and dark energy are evenly distributed across the cosmos. These components are believed to constitute around 95% of the universe's total mass energy content, yet we cannot directly observe them. Our understanding of these mysterious forces comes only from their gravitational effects on the visible universe and the cosmic expansion. The conundrum lies in the fact that neither dark matter nor dark energy can be measured directly. They are inferred from the movements and behaviors of galaxies and galaxy clusters. If these gigantic cosmic structures like the Big Ring and giant arc are not aligning with the predicted models, we must ask ourselves, might there be other forces at play in the cosmic arena that we have not yet discovered? This is a sentiment echoed by Nobel Prize-winning astrophysicist Adam Rie, who famously stated, "Now it's out. Hubble was wrong." Our long-standing perceptions of the universe are being overturned. We are on the brink of a paradigm shift in natural science, a pivotal moment that rivals the seismic shifts brought about by some of the greatest minds of the past century. Around 100 years ago, figures like Albert Einstein and Edwin Hubble were reshaping our understanding of the cosmos. Hubble himself made groundbreaking discoveries, identifying the first galaxies beyond our Milky Way, expanding our view of the universe. Today, we stand on a similar precipice, tasked with re-evaluating our cosmological models in light of new, sometimes contradictory, evidence from the cosmos. These are indeed exciting times, times of discovery and redefinition. As we continue to probe the universe with ever more sophisticated technology, each new piece of data has the potential to redraw the cosmic map. Did you know that the very concept of our universe expanding from a single point originated from the observation that distant galaxies were moving away from us? This groundbreaking insight led Edwin Hubble to propose the idea of an expanding universe, fundamentally altering our understanding of cosmic dynamics. Building upon Hubble's observations, Belgian clergyman and researcher Georges Lemaitre took the idea further, eventually formulating what would become known as the Big Bang Theory. This model has stood as the cornerstone of cosmology for decades, largely unchanged until now. Enter Nobel Prize winner Adam Rie, whose research into the Hubble effect has begun to shake the foundations of established cosmology. Rie posited that there must be crucial aspects of the universe's true nature that previous science had overlooked. The Hubble effect, which examines the rate of the universe's expansion, has shown puzzling inconsistencies. Typically, astronomers measure this expansion by using various standard candles, objects like the cosmic microwave background radiation or a specific class of stars known as Cepheid variables. In a perfectly homogeneous universe, all measurements should align, yet they do not. For years, when the Hubble Space Telescope confirmed these inconsistencies, scientists could somewhat dismiss them as measurement errors. However, as technology advanced and the data accumulated, dismissing these discrepancies as mere errors became increasingly untenable. This is more than just an anomaly. It's a sign that we may need to rethink some of the most fundamental aspects of the cosmological model. As we delve deeper into the universe's mysteries with more refined tools, we continue to uncover evidence that challenges our old paradigms. The James Webb Space Telescope, JWST, has now irrefutably confirmed what was once merely a suspicion. Discrepancies in the rate of expansion of the universe are not just anomalies, they are a stark reality that scientists can no longer ignore. These variations suggest that the universe may not be as uniform as once thought, potentially upending decades of consensus on how and why the universe expands, how galaxies are formed, and how cosmic structures come into being. For years, many researchers have revered the conclusions drawn by Einstein, Hubble, and other 20th century astrophysics pioneers, acknowledging that while they had identified key aspects of how the universe operates, their understanding represented only a fragment of the complex cosmic puzzle. Today, we stand on the brink of a paradigm shift, driven by recent findings that challenge the traditional view of the universe as a passive, inert expanse. Among the most startling of these findings is the suggestion that dark energy, previously understood as a constant force driving the accelerated expansion of the universe, might not be uniform or constant at all. This has led to some speculative but fascinating theories, including the idea that our universe might exhibit properties of intelligence, akin to a living organism. At first glance, this notion seems outlandish, yet it emerges naturally from the frontiers of current cosmological research. If dark energy varies across different parts of the universe, then the traditional model of a cosmological doubt on the constancy of dark energy, a concept once considered a cornerstone of modern cosmology. Recent data from the Dark Energy Spectroscopic Instrument, DESI, which has undertaken one of the largest 3D mappings of the universe, reveals that the properties of dark energy may have evolved over time. This revelation challenges the long-held assumption that dark energy, responsible for the accelerated expansion of the universe, is a constant force. The implications of this finding are profound and suggest that dark energy might possess dynamic qualities, exhibiting variability that Einstein and his contemporaries could never have predicted. If dark energy can change, it introduces a new layer of complexity to our understanding of the cosmos. This could very well explain the discrepancies observed in various measurements of the universe's expansion rate. The James Webb Space Telescope, known for its unparalleled ability to peer into the depths of the cosmos, has sent back a new image that has puzzled astronomers worldwide. This image reveals an anomaly that challenges our current models of the universe. The specifics of this anomaly relate to the distribution of galaxies and dark matter, which appear to be misaligned with existing cosmological theories. This finding has profound implications for the Big Bang Theory, the leading explanation of how the universe began. According to the theory, the universe should be isotropic, meaning it should look the same in all directions. However, the new image suggests there are irregularities that could hint at an unknown force or a previously undetected aspect of the universe's expansion. Dark matter, which makes up about 85% of the total mass of the universe, is invisible and detected only through its gravitational effects. The latest JWST image indicates anomalies in gravitational lensing, where light bends around dark matter. This could mean that dark matter interacts with visible matter or light in ways we do not yet understand. Today's revelation from the JWST only scratches the surface of the mysteries awaiting us in the vast expanse of our universe. As we continue to investigate these anomalies, we remain on the brink of potentially groundbreaking discoveries that could redefine our place in the cosmos. What do you think these irregularities mean? Share your thoughts in the comments below. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blisovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.